Hi there, welcome to the King's Tutorial class. In today's class, I will show you how to use Pythagoras theorem and when to use SOHCAHTOA. Now, given these two right angle triangles, we have triangle ABC, we also have triangle DEF in this case. Now, before we move into how to use Pythagoras theorem and SOHCAHTOA, let me quickly show us some of us what our angles are and then what our sides are also in that case. Now we have three angles here, ABC, where this is our angle A, this is our angle B, the right angle triangle here, and our angle C. Now for this, we have this as our angle D, our right angle triangle E, we have our angle F. Now your A can be represented as what? As BAC, or we can say it is angle BAC. So what differentiates this from this? The angle is already outside there, so I'm talking about what? Angle A. If I said you should find angle BAC, I'm looking for what? Angle A in specific. If I'm saying you should find angle BAC also, in this case, I'm also looking for what? Angle A in what? Specifically. Now, the same thing for, or we can call it, we can say it is something as CAB, you know. We can also say it's what? CAB. In this case, since A is in the middle, I'm looking for what? Angle A in that case then. Now, representations of our sides. The side opposite each angle is their what? Sides. What do I mean? This is angle B. This is side what? B. This is angle C. This is side what? C. So we represent sides with small letter. Represent angles with what? Capital letter. This is what? Angle A. For this, we have this as our side F, as our side E, and our side what? Our side D. In that case then. Now from there, let's now see what they represent. Now for our side A is the same thing as what? Side what? BC. Okay, our side small b is the same thing as our what? As side AC, and small c is the same thing as our what? Side what? AB, you know, and so on. So the same thing for this one's representation also. Okay, now let's now go to what? Pythagoras theorem and its representation. For Pythagoras theorem, we have the formula to be what? Hypotenuse squared equals what? Adjacent squared plus what? Opposite what? Squared. Now, how do I identify my hypotenuse, adjacent, and what? Opposite? Now, the first two you need to identify is what? Your hypotenuse and opposite. After which, the last side represents your what? Your adjacent. Your hypotenuse is always represented by a right angle triangle. That is, the side that opposite this right angle triangle is your what? Hypotenuse. So it means I'm going to have from that place that b squared equals what? A squared plus what? C squared. And for this, I'm going to have it as what? E squared, because E there represents my what? Hypotenuse, the longest side. So I'm going to have E squared equals what? D squared plus what? F squared. Now, for this representation, A and C can be adjacent or opposite. But for a question given as let's say I was given something like this now. I was given 24 here. I was given this as right angle triangle. This is as x. This is what? Y. This place was 60 degrees. Wherever we see this kind of arc or this kind of angle, this mostly represents our opposite, depending on what you want to use. Now, if I'm using this side as my opposite, I'll be using this angle to solve. If I'm using this side as my opposite, I'll be using this angle to what? To solve in that question. So in this case, I'm going to have this as what? 60 degrees. If I'm looking for x, now I'm going to be using this angle opposite x, and then a side that is significant, not y. So as not to complicate the issue, you understand? So I'm going to be using what? Opposite and what? Hypotenuse. And opposite and hypotenuse in that case represent what? Our sine. Okay, so let me quickly introduce my SOHCAHTOA. My SOHCAHTOA, S here represents what? Sine. C here represents what? Cosine. And T represents what? My tangent. And for my sine, I have my sine to be what? To be opposite over hypotenuse. So that's opposite over what? Hypotenuse. For my cosine, I have it as what? Adjacent over what? Hypotenuse. And for my tangent, I have it as what? Opposite over what? Adjacent. Okay. So, let's now go back to this question. So, for my SOHCAHTOA now, what will I use my SOHCAHTOA? Or what will I use my Pythagoras theorem in that case then? I'll use my Pythagoras theorem if I'm given what? Two sides, and I'm to look for the third side. That's why this formula came in. I'm going to use my SOHCAHTOA when I'm given what? A side and an angle. Just like this. A side and an angle. I'm to look for either a side, X or Y. I'm to look for what? The last angle there, which is this. Because this is already what? 90 degrees. So that's I'm going to use my SOHCAHTOA. If I'm given a side and what? An angle. Just like this. So I'm going to use SOHCAHTOA in this case here. Okay, so let's now see. What will I now do in that case? To get X, that becomes what? Opposite to what? Over what? A significant side. That's 24, which is my hypotenuse. And opposite to my hypotenuse represents my what? Sine, which gives me what? Sine 60 equals what? Opposite there is what? X. Hypotenuse there is what? Is 24. Then you solve. Now, for my y now, how do I get my y? My y, the angle opposite to my y is my what? My adjacent. Because this is the significant angle given to me in the question, which already represents my what? My opposite. So, I'm going to be using what? Adjacent and the significant side, which is what? 24. So, my 24 represents what? Hypotenuse. And that's what? Cos. Cos 60 equals what? Adjacent over hypotenuse. My adjacent there is what? Is y. So that's going to be y over what? 24. Then from there you solve. So this is why I'm going to have my x to be equals to what? 24 sine what? 60. This implies I'm going to have my y to be what? 24 cos what? 60. Okay, then when you solve, you get your what? Your answer by punching to the what? On your calculator. So that's how to basically use your Pythagoras theorem. That particular is your what? Your SOHCAHTOA.